Welcome back. Okay, I'm going to try and be a little louder this time because I've heard that my videos are kind of quiet. So let's see how this goes. Let's get to the water we use whenever this PowerPoint works. Okay, so the objectives are to identify sources of potable and non-potable water, describe the availability of water throughout the globe, and assess the impact of water consumption and diminishing supplies on human activity. So, what is potable water? Potable water is drinking water that can be consumed without risk. So basically, it's just safe water to drink. So in developed countries, potable water is supplied to houses, commerce, and industry. It's delivered by water supply systems like we're talking our infrastructure and our plumbing. It's used for drinking, washing, and irrigation. Irrigation we call gray water because that's basically just the water that we like wash our hands with and shower with. We put that into the irrigation systems. So it's really important that if you have medications, do not put those medications down your sink because those medications end up going into our fields that we grow our crops in, and then those medications stay in the soil, and then they get absorbed through the crops, and sometimes they just continue to stay in the soil and cycle through, and makes it so that we have soil that is unhealthy and unfit for growing of crops. So that's just an important side note there. Here we go. Let's get into the real bad stuff here. We've got 844 million people in the world that do not have access to safe drinking water. So, to put that in kind of context, the United States, we think that's really big, right? It has 300 million people. So, that's roughly three of our countries do not have access to safe drinking water. 2.3 billion people live without improved sanitation, so places to pee and poop, and that's roughly a little over 1/3 of our population. So it's a lot of people that we need to help out. So, what is non potable water? It's contaminated, and that's usually through human sewage. And so that's why it's really important that these 2.3 billion people get improved sanitation because it can affect these 844 million. It can grow. If these 2.3 billion people, every single one of them has a contamination issue with their sanitation supply, then we're going to have 3.1 billion people that don't have access to safe drinking water. So just think about that. So, contaminated or non-potable water will usually have high occurrences of disease vectors. So that's going to be like the flu and viruses. It's going to have pathogens, which those are more diseases. High levels of chemicals and high levels of suspended soils. So there's just a lot of stuff in that water that you don't want to be drinking. Drinking or using non potable water can and does lead to chronic illnesses and death. So we're talking cholera, typhoid fever, giardia. But these people need to drink water to survive, so they're drinking this contaminated water, risking their health to get these pretty much old world diseases that most people in developed countries do not get anymore. So there are people dying today that get diseases from old world or die from old world diseases like that. So here we just have a graph of people who do not have access to safe drinking water. So here you see throughout Africa, pretty much we have really bad incidences of non-potable water areas. So this red is about 64 to 87% of the population has no access to potable water. So right here in the Middle East here, and then right here in I don't know what country this is, like Laos or something. But I mean, anywhere from this blue to red is bad. So pretty much everywhere in the whole world has places with non-potable water. So we need to be really concerned about that, and try and help out those underdeveloped countries. If you'll notice, most developed countries, United States, Russia, Canada, Australia, pretty much everywhere in Europe, they all have potable water, and so those are the developed countries. And so here is the percentage of households in major cities that are connected to water and sewage. So in Africa, about 42% has connection to water from their house or yard. Okay, but 18% has a connection to a sewer. So that they're basically trying to find places that aren't the sewer to get rid of their excrement. And so what happens with that excrement is then it gets washed away and it goes into their water supply. And so that contaminates this water supply here. So here you'll notice Europe and North America, we have really high levels of both connections to sewers, but also house and yard connections to water. So we're doing pretty good. Usually this has to do with wealth. So if your country is more wealthy, you'll have better access to those basic needs. So, what are water sources? Well, we've got ground sources, precipitation, and ground sources and precipitation for fresh water. So, ground sources, we're going to be talking about groundwater and aquifers. So, groundwater, just to make sure that you understand this before your groundwater unit, it's just spaces within soil, like air spaces, pockets within soil that fills up with water. It's not like an underground liquid lake. That's not what an aquifer is. Sometimes we make man-made aquifers, and those are usually above ground, and those ones are just basically big pools of water. Then we have precipitation as a water source. So the precipitation really accounts for most of our surface water. So we're talking rivers, streams, and then sometimes glaciers. Glaciers feed rivers and streams as well. So potable water access. Money is a limiting factor. So it costs a lot of money to transport, deliver through pipes, and create the infrastructure underneath the ground to be able to have sewage lines, water lines, all that stuff. So if your country doesn't have money, then you're probably not going to have a lot of access to potable water, even if you do have access to water in your country. So how does water work? Well, 97% of all water on the earth is salt water, so it's ocean water. 3% of all water on earth is fresh water. Of that 3%, 77% of that is frozen. Another 22% is groundwater. 22% of the 3% of fresh water is groundwater. And then 1% of fresh water is actually lakes, rivers, and streams. So if you think about like the Great Lakes and all our biggest lakes, they seem massive, right? Well, that's 1% of all of the fresh or all of the water on Earth. It's 1% of whatever water or whatever fresh water we've got. Excuse me. So of the 3% of fresh water in the earth, 1% is available through lakes, rivers, and streams. So we mainly get our water through groundwater. That's 22% of 3%. So it's a really, really small number of water on this earth. We can't get a lot from ice caps and glaciers, and we don't want to melt those anyway. That would contribute to global warming. So here's another picture. 97% of our water in the earth is in oceans, and then the rest, that 3%, is fresh water. So 0.014% of all water is actually lakes, rivers, atmospheric water, and soil moisture. So the other 2.59% of all water on earth is going to be found in ice caps, glaciers, and groundwater. So we don't really have a lot of water to go by, just to put that in perspective. So water and wealth. We already talked about this. These developed countries, North America, Russia, Europe, they have no serious threat to their water supply. Their populations align with water resources. So you're going to see a lot of people near like rivers, lakes, anywhere where they're producing water or have water, you're going to see more people in that area. We've got these developing countries, Northern Africa, the Middle East, South Africa, north of China. They face severe water shortages. They have scarcity of resources and overpopulation. That's the big one. They have overpopulation there. So that really takes away from the fresh water being supplied. Then South America, India, southern China, and some other parts of Africa, they're also developing nations, but their economic constraints to develop safe water and their excessive population growth keep them from being able to have more supply than demand with water. So pretty much if you're in all of these countries and continents, you're not going to have as good of a chance to have your basic needs met if you're in one of these countries up here, these developed countries. So in all things considered, in this perspective, we're doing all right. So all organisms need water. Around 70% of the human body is water. Okay, so think about that the next time you choose a soda instead of a water to drink. We can survive weeks without food, but we can only survive about 3 days without water. And that kind of depends on the person, and it depends on the environment that that person lives in and their physical fitness. So if you're a bigger person, you're less physically fit, and you're from Houston, you're going to need more water. If you're really fit, you're from Chile, your body has already adapted to the water constraints, so you're going to need less water per day. But if you work out more, you're going to need more water. You're going to need more electrolytes, all that stuff. So there's a back and forth with that. So you can have too much water. You can die from having too much water. It's called water intoxication. And it's basically you have too much water in your system. It dilutes electrolytes out of your body. And electrolytes basically make everything happen in your body, so your body starts to shut down. So, in light of that H2O intoxication, just so you know, we are all robots. Okay? Electrical impulses make everything happen in our body. It's called an action potential, and it goes through our sodium potassium channels. Okay? And sodium, potassium, magnesium, there's other ones. Those are electrolytes. They're salts, basically. So if we have too much water, those electrolytes get diluted. Our kidneys filter those out. We pee them all out, and basically we burn out. We don't have anything to keep the wheels turning. Basically, it's like getting rid of gasoline in your car and just trying to run it. So with endurance athletics and overexertion, a lot of times those people are continuously drinking water, but they're also sweating, so they're getting rid of their electrolytes. So what they need to do is have a drink like Gatorade or something that has a lot of electrolytes. Gatorade has a lot of sodium in it, and that's what an electrolyte is. So it keeps your body going, basically. So here's an action potential channel. It's not super important that you know this, but I just want to make sure that everyone kind of has this basic understanding. So we get about a swing of 100 millivolts in our cells. So this is through every cell. What happens is we get sodium channels opening. So sodium goes into the cell membrane, and it creates a positive to negative reaction, which creates electricity in your cell. And so when that happens, more sodium channels open, and you get that electricity generating in your cell. It's around 30 millivolts, and that's about how much your cell can handle anyway before it burns up. And then they close, potassium channels open, which deregulate that electricity going through your cells, and so you lose that energy again. But really what's happening is that energy is just being transferred onto another cell. So you get that action potential, electricity goes into one cell, and then it goes to the next cell, to the next one, to the next one, to the next one, and that's how your muscles work and move. So here's just a diagram of action potential. This is sodium. Sodium is positively charged in a negative setting. It goes into the cell membrane. And then what we have here is this switching of electricity, basically. So the voltage goes from positive on the outside and positive on the inside, negative on the outside, to positive on the outside, negative on the inside. And so that's what's happening. That's what's creating that electricity, is that change of particles. So then you just get this action potential happening, and it's basically all about sodium and potassium, and those are electrolytes. So if you dilute your system too much, you're not going to have as many of these, and so they're not going to be able to make this happen, and you're not going to have these millivolts actually creating electricity through your cells. And so that's what H2O intoxication is. So let's talk about fresh water. It's decreasing. We have a water cycle. It tells us that water is in a loop of different states of matter. So it's in a gas in the atmosphere as water vapor. It's liquid in the ground and on the surface. It's solid in ice caps. Water is amazing this way. The problem is the demand for fresh water is exceeding its supply. So as our population goes up, fresh water goes down, and we need to change it. So how do we do that? We need to reduce consumption of fresh water. That's number one. We need to start using more wastewater treatment for that gray water. We need to protect wetlands. They're really great for holding and storing water. Reduce groundwater overdraft, so just quit taking so much out of there. And we need to work on desalination, but it costs a lot of money. And you need to use energy to make that happen, and it kind of messes with the water cycle. It takes water from the ocean and turns it into fresh water, so you don't really want to change cycles all that much. So here you go, here's the water cycle. When we take all of this fresh water out, then it goes into a different area. So it's going to be going into the atmosphere more, or the oceans more, so that's the problem. So bottled water. Over 25% of bottled water comes straight from the tap. So that means they're charging you about 1,000% more for that bottle than if you just got it for the tap. The EPA regulates tap water. The FDA regulates bottled water. So there's no regulation of bottled water that is packaged and sold in the same state. And tap water is constantly moving. Bottled water sits and becomes stagnant and allows for illnesses.